In you come then. Let's get into the workshop and let's frantically fix my lab power supply that is broken. Right, this will take 2 minutes. And while we're here, we might as well give you a quick update on the solar powered shed. We've now got speakers installed. We've got some nice blue lighting, so you can see into the wardrobes there. We've got fairy lighting to make things look pretty. We've got the double solar panel that you've probably already seen installed on the top of the shed. Everything is looking nicely racked up. We've been brewing some of our own beer, and we've got yet another audio system here, which is effectively a little Bluetooth device driving both speakers, this guy here and this guy over here. We've got managed to recondition an old 12-volt battery, and that seems to be holding its charge really well. And then up here we've got a whole shed load of Black & Decker 18650s, all on charge with solar. So happy days. And there it is, and let's start this madness. Hey everyone, this is a really dodgy power supply that I've made. It's the full build instructions. I'll try and pop a link in if I remember, up there or up there somewhere. But ultimately I blew it up. Stupid me, I connected it to a 12-volt battery, and the wrong way round if I'm not mistaken. So it doesn't work properly anymore. Let me just show you what it does. So I try not to electrocute myself. Hopefully you can see some numbers there. Zoom in a little bit. Right, so you can turn the display on and off, and you can look at the input voltage and the output voltage, which is the voltage on those terminals there. And then with this wheelie-dealy knob here, you can adjust the output voltage between 1.5 and 24 volts. Now, the deal is, I'm such a muppet. I blew it up, as I said. So let's just unplug it, because right now it's got mains electricity running through it. So we'll unplug it and let's have a quick look inside. So what have we got inside? We have got a switch mode power supply, and you'll have to excuse the sound of various vehicles and people and screaming children and that kind of stuff. I'm in the shed, I'm just throwing this video together really quickly. And this is a lovely little Bourne's 10-turn potentiometer here. And this here is the guy that's blown. So what we've got to do is replace it. But it's a very useful tool to have in your kit. Thankfully, these PCBs are all of about sort of 3 or 4 quid, so it shouldn't be too much of a hardship just to get in here, undo all of the various screws and bits and bobs, and remove the PCB and chuck a new one in its place. The switch mode is rated at about 3 amps, so let's just pop all of those out and just double checking down the bottom there to make sure that that is not plugged in any way, shape or form. So the first thing we've got to do is whoops, oh there we go, pull the cable off. So the first thing we've got to do is remove this little potentiometer here and replace it with the big potentiometer by fitting that on those pins there. And then the easy bit, actually, well, the easy bit is removing these guys, which is the output, and as you can see they're really thick cables, probably a little bit too thick if I'm completely honest with you. So let's just pop those off. Now what did I put that bit of tape there for? I don't know, but let's hang on to that, might be useful at some point. Oh, and great news, so this is the these are the connections from the power supply side. So blue at the top, remember that, blue at the top, and brown at the bottom. Oh, I've I've soldered those on. Right, okay, let's just see if we can pop those bad boys off with the soldering iron. Yes, indeed we can. Good, they're off. So it was blue at the top and brown at the bottom when the PCB was this way around. So let's just let's poke those in the holes and screwdriver them in place. Shouldn't be a big problem. Happy days. So this is the input voltage or the input power coming from the switch mode power supply, and that needs opening up just a little bit more. That power supply there is 24 volts, so that makes sense that this is 24 volts to 1.5 volts. I mean, what a great range though, because you know you can set it for 5 volts power stuff, you know, like USB bits of kit, maybe even power a small display off of it, like a little laptop display or something along those lines. The other thing I think I'm going to do actually is these cables here are a little bit messy, so I think I'm just going to touch those with a little bit of solder just to make them a little bit prettier. So this is going to be a midweek release, and and it's at that sort of time, it's sort of rush hour when everybody is travelling to and from work. So, ooh, hang on, that says out. I've got that the wrong way around, clearly. Idiot, wow. Okay, let's put these in the right way around then. So we want these on the input side of things, not on the output side of things, because I'm rushing and trying to make this a short, sweet video. Anyway, hope everybody is all well and having fun and staying safe and staying home and all that kind of good stuff. I've just finished up a Famicom refurb. Actually fantastic, because it was a really old collaboration with Neil from RMC, from Retro Man Cave, and also a guy called Control Alt Reese. In fact, I'm trying to do quite a lot of Skype calls with people at the moment and enjoy collaborations with people. Right, so out, positive, that side. That's a bit of a fat, hairy joint, Howard. No comment on that comment. Right, out there, and let's shove that in the hole. No comment on that comment either. Come on, get in there. That's what she said. And there she is. That's one in. Yeah, these cables are a little bit thick, really. But yeah, it's I think it's just a buck device, so it just basically reduces power down. There we go. That's nicely shoved in. Let's tighten it down. Okay, very good. Right, make sure that's solid. That's solid. The input side is absolutely solid. Right, the next part of this mission is to remove this potentiometer. And we will do that. And you know what I hate? I hate lead-free solder. I'm looking at the other side of this PCB and I can see that all of this stuff here is lead-free solder. In fact, what I'm going to do, I'm just going to put a large blob of solder on the soldering iron, and then I'm going to hit this potentiometer all over the PCB. Look at that, boom, off in a heartbeat. Who needs a solder sucker? Right, there we go, component removal. And now what we've got to do is connect in. Now this was the middle pin, if I'm not mistaken. Yep, that's the middle. It'd be good if I'd perhaps colour coded those a little bit better. Right, let's just see, how are we doing this? We're doing it like that. So this is the middle pin. Let's get the orientation correct. And if I remember correctly, I think actually it was the wrong way around. So when you rotated clockwise, the voltage went down, and when you rotated anti-clockwise, the voltage went up. So let's see if we can fix that as well. So that would have been that guy. So what we'll do then is we'll put that there instead. So we're just swapping the two ends of those connectors around. And there we go, one on there. I know this is an absolute riot, isn't it? Yeah. Just, there we go, got rid of that old broken PCB. It'd be interesting to actually figure out what's wrong with that PCB, because it is reading voltages correctly. Okay, happy days. Right, let's screw that, screw it right up. Let's screw that back in place. Oh, hang on a minute. Right, I've got buttons. So I 3D printed some little buttons for this. One goes there. Where's the other button gone then? Ah, yeah, okay. Right, lost a button. There it is. Oh, thank goodness for that. Didn't want to have to try and 3D print another button. Right, so those are the buttons back in place, and those buttons clearly align with those little push buttons there and there. I mean, this is just sort of worth the £3 or £4, just because it's got an LED display on it. Anyway, right, let's align that up there, put a couple of screws in it. I think the screen for the display on this, I think I used an old bit of plastic, like a bit of Coke bottle or something along those lines. Come on, in you go. Right, one in there and one in there. And brewing beer. Did I mention brewing beer? I'm brewing my own beer. Right, no idea what that little bit of black tape was for. Didn't seem to make a lot of sense. Haven't really looked at it properly, but it is what it is. Right, let's chuck that around. And the other thing you'll notice, there's no fuses in here. There's no real cable restraints. There is an earth, but that's only connected to the power supply, and I'm not sure it entirely touches the body either. But this is dubious engineering, guys and girls, so don't do what I do, but perhaps you might want to add a little bit of extra professionalism to your work, I'm not sure. And the other thing, actually, part of the reason why I wanted to do this was because somebody said in the comments section some time ago, can you put together a BMS? So here is a BMS. That's a battery management circuit, by the way, for lithium-ion cells, this guy right here. So I've done that, and I'm happy with that guy. Right, let's plug this in, turn it on, and see what happens. Boom! Right, so there we go, check it out. So when we go left, the voltage goes down. Okay, happy days. Down to 1.3 volts, and when we turn it to the right, the voltage goes up. But yeah, alright, good. So let's just check. The input voltage is 24 volts. Let's just zoom you in a little bit so you can see what's going on there then. So the input voltage is 24 volts. The output voltage is currently 1.3 volts. That's turned right the way down to 1.2. So that should be the output voltage for these two terminals here. If I move that over to the side, bring in the Fluke 77 and pop those in the holes. Let's see, yeah, 3.7, 3.7, 7.6, 7.7, yeah, agreed. And let's just get this all the way up to 20 something volts. Look at that, 18, 19, 20, yeah, so about 20 volts is about our maximum voltage. But that appears to be approximately correct. So you know what, at that point, I'm going to say happy days. Alright, so because this almost sort of works, this PCB, this old PCB, because it almost sort of works, I thought I'd just have a quick visual inspection of the PCB and look at this. Quite clearly it has blown a component, and I can only guess that that would be a diode. So I believe I can chuck a replacement diode in here, and it doesn't have to be surface mount. And with a little bit of luck, that'll actually fix things. And I'll end up with a PCB that works again. Happy days. Alright, okay, I know, as this is a somewhat dubious sort of show, I went through my diode collection and I found this guy here. So the plan is to replace this guy. I'm going to need one of them and a fat hairy chisel tip soldering iron. Okay, let's see if we can do this. Alright, that's the old one removed. It wasn't too hard. So I'll solder down. Just chuck a bit of solder on there. On these leads. Out, that lead got hot very quickly, as you'd sort of imagine. As you can see, the diode symbol says squeaky fan belt time. It says left to right. So right, go sort your fan belt out, mate. Look at that, boom! One leg down. Right, I've got to just do the other one now. I got it, yes, I got it. Happy days. There we go, boys and girls. Fixed. A little bit burnt, a little bit smouldery. But look at that, absolutely solid. So let's remove that. And there we have it. That should be good to go again. Yeah, I genuinely forgot about the variable resistor that I removed earlier, so just gonna chuck one of those, chuck the one off of the board that I just replaced, chuck that one there like that, and look at that, Mr. Blobby came with his soldering iron. Mr. Blobby came with his soldering iron. He burnt the potentiometer. But you know what? He's got it. A chisel tip. Tell you what. Look how big the tip of that soldering iron is. It's a monster and it's dirty. Did the trick though. Yeah, and here's the gardening project that I wanted to tell you about. So ultimately then, it's literally just like a little greenhouse made out of scraps of wood. We've got lettuce, we've got cilantro, beans and stuff, and a rather sad looking tomato plant over there. Anyway, you don't really want to see gardening, do you? But I was quite impressed with that enclosure that I managed to put together. Chuck in the last couple of screws. Thanks ever so much for watching. Make sure you give us a thumbs up. Make sure you subscribe if you haven't already. And we'll see you on the next one. Take care, people. Cheers and beers. Bye for now. Sorry for a frantic episode.